I am Arobi. I will be representing the Tivoli Free Library. This is uh, in collaboration with COVID Communications, a team of biologists from Northwestern University. Thank you so much for joining us today. I know there's a lot of communication happening about COVID-19, the vaccines, everything, and so it's great to have some scientists here to kind of clear up and give us actual science behind this virus and the vaccines. So thank you. Um, if anybody who is attending has questions, feel free to use the Q&A function down at the bottom of the Zoom call. This will be recorded, so I just want to let you know. We will not be sharing this out, putting it on YouTube, etc. But if you do request a recording, if you are attending, you can email me at tivoliprograms@gmail.com to ask for that. But yeah, otherwise, COVID Communications, take it away.
Yeah, so my name is Catherine. I'm the leader of COVID Communications. And today we have, a great team of scientists with me, and we'll be explaining the science of COVID-19. So some housekeeping things. Please, if you have any questions at any point in this event, please put them in the Q&A and we will answer them live once we are done with our presentation. And yeah, so I'm gonna start presenting. All right, so thank you again for coming to our event. And we will be talking about COVID-19, what it is, and the vaccines today. So as Arobi mentioned, we are COVID Communications, which is a team of biology PhD students, and we come from Northwestern University, which is in Evanston, Illinois. So we have all received a bachelor's either in science or arts in biology and or other STEM related fields. So we all have a great understanding of general understanding of biology and have done extensive research to bring to you current and accurate information on the coronavirus and the vaccines. Today, again, my name is Catherine and I'm joined by Sitlai, who will moderate this session, Frank, who will help moderate the chat and your questions, and Natalie, who will be joining me in answering some of the questions you have. But again, a lot of our research has been done by many other members of our team who cannot be here today, but we thank them for their hard work and support. So let's dive right in. And so I want to bring it back to this basic biological concepts and kind of discuss what DNA and RNA is, because I'm sure you've heard of it before. And so to remind you, DNA is the genetic material that makes us who we are. And your DNA is housed in this structure called the nucleus, which is separate in your cell. So it's separated from the other contents of your cells in this kind of sequestered area. And from your DNA, you can make mRNA or messenger RNA. And these are short instructions that are from your DNA that are an intermediate to make something called a protein, which are the active particles in your cells that perform the functions that help us keep us alive. So an analogy for this process, which we call the central dogma of biology, is that your DNA is this large instructions manual. And your mRNA is page probably like 17 of your manual that tells you how to make a table. And the protein itself is the end product or the table. And you can use that to do many other functions that are required for your body. So hopefully that is helpful for you to understand what these three molecular things are. So what is a virus and how does it play into this process? So viruses are molecules that hijack your cells. And they're very selfish because they use your cells to produce more of themselves. And what's really interesting about viruses is that they cannot replicate outside of your body, but can only do it by taking control of your machinery, your cellular machinery. And so obviously that is bad for your body. And so your body responds by increasing the body temperature, or what we know as a fever. So hopefully it can deactivate these viruses and prevent them from replicating. It also causes inflammation, which in turn helps and kickstarts your by activating your immune system, which will find ways to fight and kill this virus before it causes too much damage. So obviously we've been living in this pandemic for a while. And so we know about COVID-19 and SARS-CoV-2, but what specifically are these terms? So COVID-19 refers to the respiratory illness that is caused, whereas the illness is caused by the SARS-CoV-2 virus. And SARS-CoV-2 stands for Severe Active Respiratory Syndrome, Coronavirus 2. And so what happens in your body is that a SARS-CoV-2 viral particle enters your cells using the spike protein, and then uses your cellular machinery to replicate itself and cause damage, and hopefully propagate enough so that it can go on and infect more cells and make more of itself. So SARS-CoV-2 is a type of virus which we call coronavirus. And coronaviruses are RNA viruses. And they're called coronaviruses because when scientists looked under the microscope, as you can see in this image, it reminded them of a solar eclipse. And this is actually not the first time we've seen coronaviruses. There are actually many different viruses that we have dealt with before, which include the common cold. So, what are the symptoms of COVID-19? And you probably heard many of these before because we've been living in this pandemic for the last year or so. But we'll reiterate some known symptoms. It can cause cough, fever, chills, and muscle pain, as well as shortness of breath or difficulty breathing, a sore throat, or loss of taste or smell. So how do we fight COVID-19 and SARS-CoV-2? So that's with the 3 W's, which is watch your distance, wash your hands, and wear a mask. And of course, now we have new and exciting way to fight coronavirus or COVID-19, and that's through vaccines. So what is a vaccine and how do they work? So vaccines are a safe and effective way to train your immune system to identify and destroy a specific disease-causing microorganism, such as a virus. So in this infographic here, we're actually displaying the process that scientists use to create the COVID-19 vaccine. And so at first, scientists took fragments of the instructions for a part of the virus called the spike protein. So it's only taking, one small part of it, not the whole virus, and disseminating into either mRNA or DNA instructions. And then the vaccines are made, which are injected into your muscle, into your body. And the vaccines are to deliver these instructions to our cells. And so for the Moderna and Pfizer vaccine, it's an mRNA-based vaccine, whereas the Johnson & Johnson is a DNA-based vaccine. So once these instructions are in our cells will then take it to make a fragment of the virus again, which is only the spike protein. And then as these are made, your immune system will start to realize that it is foreign material and will want to destroy it. And so now your immune system will produce things called antibodies and T cells to destroy the spike protein. And within this process, it will train your body to recognize SARS-CoV-2 and what it looks like. And so the end product that we hope to get is memory cells, which have the antibodies that the antigens that will be used to kill the spike protein or SARS-CoV-2, and it will remember how to do that in the future. So the point of having these vaccines is to create an immune response, so that when you encounter actual active virus, it will have a quicker and stronger immune response. And so in this curve, this is kind of illustration of how your immune system will respond. So in this first exposure, which in this case will hopefully be by vaccine, you have this slow and low response from your immune system. But hopefully once your body is trained to recognize SARS-CoV-2, the next time if you ever encounter this virus, it will have a stronger and much quicker response to eliminate the virus from your body. So in the US, there are 3 different COVID vaccines that are approved for use. That is Pfizer, Moderna, and Johnson & Johnson. Again, Pfizer and Moderna are RNA type vaccines, whereas Johnson & Johnson is DNA vaccines. Similarly, Pfizer and Moderna require 2 doses for full immunity, and Johnson & Johnson requires 1 dose. And so after you get fully vaccinated, there's actually a lag time between when you receive your final dose versus when you finally are fully protected or fully immunized. And for Pfizer and Moderna, that would be 2 weeks or 14 days after your second dose, whereas Johnson & Johnson is 29 days after you get vaccinated. And some numbers that we've heard probably around is something called vaccine efficacy. And so Pfizer is 95% effective, where Moderna is 94% effective, and Johnson & Johnson is 72% effective. But actually, there's a little more complexity to vaccine efficacy, so I want to talk more specifically about what these numbers really mean. So when they do clinical trials testing for the efficacy of vaccines, they can look at many different metrics. And so these numbers, 95%, 94%, and 72% that you've been hearing actually correlate to how effective is the vaccine at preventing symptomatic COVID-19. So 95% effectiveness relates to, if you have the vaccine, it's 95% effective at preventing symptomatic COVID-19. And that is the same for Moderna and Johnson & Johnson. However, you can measure other things like how good is the vaccine at preventing severe COVID-19 or hospitalization due to COVID-19. And for both of these metrics, all 3, for Pfizer and Moderna, they are 100% effective at preventing severe COVID-19 as well as hospitalization due to COVID-19. And Johnson & Johnson is 86% effective at preventing severe COVID-19 and 100% effective at preventing hospitalization due to COVID-19. So what this says is that these vaccines are extremely effective at preventing death due to COVID-19. It will keep you out of the hospital if you're fully immunized, and they are quite effective at preventing severe COVID-19, but you may or may not eventually be symptomatic and present symptomatic COVID, but at very low rates. So that's really exciting. So now that if you've been immunized, what can you do? So what you can do now if you've been fully immunized is that you can be indoors with other immunized people without a mask. You can be indoors with one unvaccinated household without a mask, and you don't need to quarantine post-exposure to COVID or after traveling. And these guidelines are from the CDC, and we checked as of March 2021. But what stays the same is that you still need to wear masks and socially distance in public. You should actively avoid large gatherings or parties. You should avoid traveling unless necessary and still monitor yourself for COVID-19 symptoms. So, as more people get immunized, we talk about and vaccinated, we talk about how does life return to normal, and how life returns to normal is through this concept called herd immunity. So herd immunity is when a large part of the population is immune to a specific disease. So in this case, for COVID-19. And this allows for the prevention of a mass spread of the virus. So we would be out of the pandemic if we reached herd immunity. And so how this works is that in a not immunized community, we have people who are able to get infected to the virus, and it can actively, rapidly spread throughout the population because people can continue to infect others in kind of this chain cascade. But in a protected community, where most people are immunized, one person who can get infected, they can only infect a few other people. And so this this prevents the mass spread of the virus to other people, so people don't get sick as much. And so hopefully we can reach this herd immunity very soon, and we can all do our part by getting vaccinated when it's readily available for us. So thank you for listening, and we'll be happy to take any questions. We want to be here for you and kind of ease your concerns or answer any questions you have about the vaccine or COVID-19. And so feel free to type your questions in the Q&A box. And thank you for coming and listening. Stop my screen share.
All right, so we'll start with the first question that we have. So it's, with so many variants around, should I still get the vaccine?
So there are a lot of variants, and as Catherine was explaining, these viruses, what changes is this spike protein that's on the outside, and that can change how it looks like to your body. And although sometimes the spike protein does change, it looks like it's too early to really determine if the vaccines that are around right now protect against these viruses or not. But we know that right now the vaccines are like completely making sure that you're not going to the hospital. So definitely go get a vaccine. It'll prevent you from hospitalization, anything severe. There is that like 5%, maybe with Johnson & Johnson, like 30% chance of getting some symptomatic COVID, but you're really reducing your chance of anything bigger.
Yeah, it's also interesting because these variants arise from basically unfaithful replication of the viruses. And so it's important for everyone to get vaccinated because then the virus can't replicate. And if it has a lower probability of replicating, you actually have a lower chance of having new variants arise and pop up. And so that will also help get us out of this pandemic.
I had a question. At what point, I guess, what percentage of the population needs to get vaccinated in order for us to reach herd immunity?
So it's said that it's about 80%. So Catherine was showing this little infographic. The way I think about it is if like someone has like a water gun and is shooting into the crowd, but if all of us have like our rain suits on, like we're not gonna get wet. So like we can't really like get other people like, all upset. But like if there's one person, they can hide amongst the people that are all like in our raincoats. But if no one's wearing raincoats, everyone around you is going to get wet from the water gun. So it's better if everyone who can get vaccinated does.
So what we're also seeing is that it's like state by state cases, right? So 80% of a state or 80% of the nation, or does it really matter because it's a percentage?
So this is just like a guesstimate. So it's not really like precise, but it should be each community, at least 80% should be vaccinated.
I think in this case, we're talking about 80% of the nation. But obviously due to international travel and all those other factors where you can bring in variants and bring in actually COVID-19 from other countries, so I think in the end we're going to have to try to get everyone internationally vaccinated before we are full and clear out of the woods. Yeah.
Okay, and a lot of these questions that I'm gonna bring up are like questions that I've heard from patrons who just pass the library often. So a lot of them have been wondering like what really is the difference between the Moderna, Pfizer, and the J&J. I think a lot of people are also just scared of getting the J&J because of all of the adverse reactions. So do you have any kind of advice or just any kind of reassurance as to what we should be getting? What should we be paying attention to?
I feel like the best vaccine to get is the one that's available to you. Honestly, like, yes, J&J has a lower efficacy, but like there's actually this great video on Vox that explains how efficacy works. And Moderna and Pfizer were both made around the same time, tested around the same time in the US, where there was really only one major like virus type around. And that's why they're very similar in how they protect. However, Johnson and Johnson, it was tested in a lot of other countries where there were other variants around. So that kind of like forces the statistics to look different because some of the virus's variants, as we know, can escape this kind of like vaccine protection. So it looks like they're less effective, but really J&J is preventing hospitalization as well, which is like our major concern.
Yeah, I think it's also important to realize like, Pfizer and Moderna, they made a conscious effort to make 2 doses of a vaccine instead of 1. And so I would think that if Johnson and Johnson had also made the same effort, that their efficacy would be much higher as well. And I think, yeah, Natalie is also very correct on saying like the different variants have caused different numbers to occur, and they were tested in different times. But I think the take home message is that they are very good at preventing hospitalizations, death, and severe COVID-19. And in essence, that is the most important thing, to keep yourself healthy. And unfortunately, being sick, no one ever likes being sick, but there is always that risk of eventually getting sick because we can't predict how your immune system responds, even with a vaccine. And to also mention, like, other vaccines that we have are actually probably less effective than most of the vaccines that are available for COVID-19. So your I think flu vaccine is sometimes not as effective, but it is very critical to preventing death and severe COVID-19, which have long-term effects on your body. Yeah, so that's great.
Okay, well, to piggyback off of that, like unfortunately, a lot of people are comparing COVID-19 to the flu. And so can you provide any kind of scientific backing to how true that statement is or how false that statement is?
So I guess what I want to say is that yes, there's similarities. However, you cannot compare how dangerous each of them is. The parts that are similar are yes, they're similar viruses. Yes, because they're RNA viruses, that means that mutations occur a lot. That's what variants mean. And lots of the mutations honestly don't really change how effective the virus is at spreading or how dangerous it is. But like a lot of people die from the flu. And actually, one of the great things about masks is this year, I read a statistic that said only one child died from the flu this year, as opposed to normally it's thousands. So both are aerosolized, which means as we talk, spit, whatever, you can spread the virus, and masks are a really good barrier to that. However, with COVID, there's just a significant chance that if you were symptomatic, there is the possibility that it evades your immune system at the beginning, which means that you have more virus in your system, and that could lead to hospitalization later on.
So we've got another really good question coming through, and that is, can vaccines change your DNA?
So luckily, no. I think that's a very common misconception, and no vaccines do not change your DNA. So the mRNA vaccines are the messengers or the blueprints, and mRNA doesn't really last very long. So your body is it's part of its normal function to get rid of things it knows it's not made by itself. So it will recognize the RNA and destroy it. It's not a very stable thing, so it doesn't last very long in your body. For Johnson & Johnson, it's a DNA vector, but the same process is true. It has no way of just being around for a long time, or somehow getting into your DNA and changing it.
Yeah, I think it's also very important to note that your DNA is housed in the nucleus, which is very selective about what it lets in and also out, but mostly in it. And so for it to make long-lasting changes in your DNA, the vaccine has to be able to get into the nucleus and be stable enough to insert itself and remain there, which has been tested. And because it's mRNA vector, mRNA, as Natalie mentioned, is not very stable. It gets degraded constantly. Even the mRNA in your body does not stay very long. That's why we have such high, low refrigeration temperatures for these vaccines, because it's not stable. And so it's the same in your body. Your body actively destroys and recycles and makes new mRNA every moment. And so this process has been very great, so that it doesn't stay around all the time. Yeah.
I also had a question about long-term effects. What do you guys have to say about long-term effects? If we should be anxious about that, if we should be preventing our kids from getting that because of the long-term effects, etc.
Do you mean long-term effects of the vaccine or of COVID-19?
Of the vaccines.
Okay. Actually, what was super interesting to hear when I was listening to a video from Dr. Fauci, he mentioned that actually, vaccines don't usually cause an effect randomly more than 3 months after administration. And so most of the effects caused by the vaccine are short-term, within 1 to 2 weeks. And usually, they've never seen a case since the beginning of vaccines where something randomly popped up and caused, adverse effect, 3-4 years beyond vaccination. And so, common side effects of, short-term side effects of vaccine are, injection site pain, muscle soreness, redness, and that is an tiredness, fevers, and that is also just your body trying to, get rid of what they see as foreign material, which is what we want. And so you have these mock symptoms of being infected and being kind of like what you would expect to do when you have COVID, because your body is trying to get rid of it, but you're not actually infected with COVID, because that's the whole point of the vaccine, is to provide a safe way for your body to recognize the virus without actually being infected.
All right, so our next question is, can you please explain why there are variants that exist? And to add on to that, are variants a big problem or a normal part of the virus moving across the world?
So we talked a little bit about it, but basically variants are very normal. So this virus has an RNA genome, which means that as soon as it starts getting into your body, it starts making pieces of itself. And when it's replicating, it's like basically typing super, super fast on a computer. Sometimes you just make mistakes. And the more virus particles there are, you keep making more mistakes. So sometimes these mistakes are good. Sometimes, most of the time, they don't really do anything. And the mistakes that we call variants, or the ones that we're like worried about, are the ones that happen on the spike protein. And we're worried about that because all of our vaccines have been against the spike protein. So if there's enough mistakes that happen and that changes how the spike protein looks to our body, then that could change the vaccine efficacy. But so far, there's no real research to say that these vaccines will not be able to cover some of their variants. And especially for mRNA vaccines, we know that since they've been made pretty quickly, they can be adapted to change to other variants in the future.
So how possible is it for a vaccine to lose its efficacy against the variants?
It really depends on what the mutations are. Like, you know, spike proteins can change to a point where the vaccine and your body can no longer recognize them. Currently, you know, we see a dip in efficacy because of these changes, but it's not like, but your body can still recognize them to enough of a point where it can still destroy it, although slower and not as effective. But we will have to see, just kind of by keeping track of the new variants that come up and also keeping track of death rates. And there are, I'm sure, many scientists and public health and epidemiologists, experts that are keeping track of this worldwide, and making sure that our vaccines are up to date, and are still effective against things that pop up and are coming as we move along in this pandemic, basically.
Okay, gotcha. I had another question. This is actually these are questions that like come from my immediate family who they have a child and they're actually worried about vaccinating, or when it comes to vaccinate the child, especially now that it seems like schools might be asking for mandatory vaccinations. Does the vaccine work differently for kids? Does it affect them differently, or does the efficacy stay the same?
Actually, you know, that's really interesting. All I can really say right now is that the CDC has looked at a study that I think Pfizer put out, that showed that between ages 12 and 16, I believe, that the vaccine is 100% effective at preventing COVID, and think symptomatic COVID-19. So it is highly effective in young adults and teens. For anything younger than that, I would say, you know, there needs to be a clinical trial for that before we can say anything. But, you know, if we're looking at it from a science perspective, technically, you know, in the science view, it should work exactly the same as it does in adults. You know, again, everyone's immune system reacts a little differently, so there might be variation in, you know, the short-term side effects or how they react. But, you know, the end product that we want from the vaccines is this memory cell that remembers how to fight COVID-19. And so through vaccines, we should be able to get that regardless of age.
Gotcha. Well, okay, well, you brought up CDC. I know a lot of people have reservations listening to CDC anymore because there's been so much flip-flopping of what they have said, what they have suggested. The guidelines have changed. How do you guys feel about that? Like, because they're technically scientists as well, and they're saying a lot of contradicting messages.
Yeah, so I think it's super interesting because, you know, this the CDC is like this governing body that overlooks many different studies, and they're kind of just the authority where they like review all these studies, and they do run studies of their own. But it was really interesting looking at the beginning because it's just kind of science at play on a global stage. And so actually this happens in every scientific process. We have, as scientists, have different disagreements in how to interpret results or how to do experiments or how the analytics are performed, because it's very different depending on, you can do the same experiment, but you can look at many different things. And then you can do them slightly differently because, you're not using the same exact people to do it. You're not using the same exact lab animals to do it. You're not using the same exact, even the reagents in the lab, like, if you make table salt from one lab to the next, it's a slightly different and is not exactly the same. So there's a little bit of variation, but it was really interesting to see because it was science, normal science at play. We disagree, people think one thing versus another. But I think eventually we did get to a consensus on what it was. Unfortunately, there was a lot of flip-flopping at the beginning because, it was brand new. There were so many studies coming out. And there was just so much data that we had to sit through and not enough kind of confirmation of what it actually was. And so, it's really unfortunate that people got confused and that, this was played at such an important point on the global stage, really. But eventually, I think in the end, science always works itself out, and we all get to a consensus with more and more data. I think it's also important to note that, this is not a topic where we study once and then drop it and never look at it ever again, because it's so important to our daily life right now. You have billions of scientists all over the world kind of constantly keeping track of numbers, constantly keeping track of the science. And so even with vaccines, like, we have people started getting vaccinated since January, and they're also the people who got vaccinated even before then in the clinical trials. It's not like those clinicians who gave the initial vaccine just stopped tracking them or studying them. They probably still keep up with them and saying, like, do you have any adverse side effects? Do you, experience anything out of the ordinary? So we have a little bit of a heads up if there is something big coming. Yeah.
Gotcha. Okay, well, one of the most recent flip-flopping that happened was about this whole J&J vaccine, right? So a lot of sites have shut down because of the adverse reactions. Can you say anything on that?
So J&J is different in how it's delivered, and also because it's one dose. So basically, what you're doing to your immune system, which is different from having two doses. In two doses, you're saying, hey, recognize this dose. This is a little bit of a spike protein, and you're giving your body a chance to first identify it, try to have your innate immune system, which is the one that like does fever, inflammation, redness, a chance to kick in. Then you're like, okay, now my adaptive immune system, or the one that has more specific memory that carries on for months, maybe a year, we don't really know yet, time to kick in as well and remember that. Then during the second dose, your body's like, oh, I remember the first dose. Perfect. This is the same exact thing. I know what to do. And it mounts this very specific response. However, for J&J, you're just giving that one shot. So it's very possible that you're going to have more adverse effects because you're hoping that your body just like mounts your initial response and your memory response and just is fighting all at the same time. So yes, J&J is going to have more adverse reactions, but also, like I said before, since it was tested at a different time in different countries, basically there's a lot more, when you have your control group and your test group, you treat half of them and you're like, okay, go out in public, let's see how many of you get COVID. And then a certain percentage of them will get COVID. And because there's more virus around at that time, it was a higher likelihood that they would encounter another person that had virus, and then they would get sick. So there's still a good coverage that comes from J&J, even if there is an adverse response.
And I think it's important to remember, like, some adverse responses are what we expect. And, And so like, fever, chills, those are kind of normal things that your body does to get rid of viruses, to react to viruses. So while it is unfortunate that we have these responses, really the only kind of side effects that we should be concerned about are the ones that aren't due to your body kind of trying to get rid of the virus. So and of course there are governing bodies, including CDC, WHO, and probably FDA, that keep track of all the data and seeing like how many people are getting allergic reactions or how many people are dying due to the vaccine, and then making decisions on seeing if this is a pattern with the vaccine, or if this is something normal to be expected. And there's a pattern of having injection site pain, of having sore arm or arm soreness. But again, those are not really something to be concerned about in terms of the vaccine, because I got my blood drawn today and my arm hurts, and that's just because of needles going into your arm, getting your blood drawn, and stuff like that. But that is to be expected. So really, the only adverse effects that we should be really concerned about are things that cause more severe and out of the ordinary responses.
Got it.
All right, we've got another question coming through in the chat, and that is, where can I get a vaccine in my area?
So,
Go ahead.
I was gonna say I was most successful by just going to Walgreens. So if you go online and you put in your address, and it honestly, like most Walgreens, they update every day, sometimes multiple times a day. I feel like that's a lot more easy to get to than going through whatever state websites there are. Maybe does Arobi know about this?
Mm-hmm. Yeah. So if you're living in the Dutchess County, definitely go onto the Dutchess County website. A lot of Pfizer vaccines are being distributed in Ulster County, in New Paltz, and different places. If you sign up for the notifications, then you'll definitely be able to get a text message telling you where they have appointments available. Right now, appointments are opening up in a lot of places, especially Best Buy in Kingston. So look out for that. But sometimes you can go from county to county to see where you can get it. I got mine in Columbia County. I'm not sure if you actually have to be a resident of Columbia County to get it, but at all of the community colleges, they've turned them into centers. So definitely call them and see if they have any appointments available for soon. I know Dutchess County is opening up a lot more places, so that's kind of nice. Tivoli Library is in Dutchess County, but it borders Columbia County, so definitely feel free to check out Columbia County as well. Yeah.
Yeah, so while we're on this topic, why don't I think I wanted to know, like, what was your experience, especially Roby, since you're in that area, what was your experience getting the vaccine, and like how do you feel? What your if you want to share how you got it, and how do you feel, basically?
Yeah. Well, I got it before my age group was eligible. I got it because I'm working at a university as well as a public facing library. We're one of the few libraries that actually opened up to the public, so that helped. But I got it in Columbia County at Columbia Green Community College. They opened up their whole gymnasium to I think about 1,000 doses that day. So that's kind of nice. It was very easy. It was like an assembly line. Everything was clean. Everything was organized. You were basically in and out within like 30 minutes. So that was kind of nice. I mean, in terms of effects, all I felt was a sore arm and fatigue. But I haven't gotten my second shot, and I think that's the one everyone's dreading. I think a lot of people are kind of scared of the effects that they'll get from the second dose, because some people have been bedridden, or like the chills and the fever was so high that they wouldn't be able to make it to work. So but that's how you know it's working, right?
Yeah, I mean, as I mentioned before, you know, when you get the second dose, that's the second time your body has seen the virus. And so your body now knows how to fight the virus and it recognizes it and immediately comes like, kill it like all out war kind of. And so that's why we feel like all these pains and aches and fevers. And that's because your immune system is going full blast. Whereas the first time, you know, the symptoms probably like show up like slower, because your body's still recognizing, you know, is this foreign, or how do we fight it? How do we kill it? And so that takes a bit of time. Whereas the second time, you know, it knows how to fight it, it recognizes it, and now it's full out war. And so, yeah, those effects are unfortunate. But don't be afraid, even if you don't get those effects. You know, your body's still working, but it's more likely that when people get the second dose, that they feel kind of pain and feel not great, unfortunately, because the things that your body does to fight off a virus also make you feel bad. So yeah.
Gotcha. Yeah. Well, I mean, I think people are also scared of some of the symptoms being a little too intense. Should any of these effects be intense? Like if your body is really having a hard time, maybe for a week even, is that normal?
So, yes, it's totally normal. Also, like, I know it's easy to compare against your friends or coworkers that have been vaccinated and how your symptoms are different, but like everyone's different. So the first line of defense is your innate immune system, and that kicks in the first first hour to a couple days. But then the adaptive one, which is what the memory like we're really trying to elicit, comes on between 7 and 14 days. So you might still be feeling a little iffy 14 days later, and that's completely okay. It just means your body needed a little bit more time to like really remember and fight whatever it's fighting. In this case, COVID. But yeah, don't compare. Even if someone's like, oh yes, mine is working extra hard because I have, more swelling, I'm more tired than you. It's really like person to person, genetic differences. uh, People can be even slightly allergic to some of the components in a vaccine. It's really hard to tell. I don't know if there's any good metrics out there that can tell you how long you will feel not great for, depending on your circumstances. But if it passes like 2 months, then you are falling under that adverse effects. And that's really, you should have been contacting a doctor. If it's more than 14 days, but 2 months, that could mean something more long lasting.
Gotcha.
I think
Gotcha.
it's also like, you know, you should, you know, if you don't feel good more than a couple of days and it's really hindering your life, I think it's a good idea to always, you know, contact your doctor and be like, hey, you know, I'm feeling this way, I got the vaccine, you know, is this normal? Or, you know, is there something I can take to make yourself feel better? You know, you can always take, you know, Advil, not giving medical advice actually, but you know, like you can there are ways to make yourself feel better, but if it's really hindering your life, you should really contact a doctor, and ask them if this is normal or what to do next, and listen to their advice. But yeah, we're not medical
Gotcha.
doctors, so we will not give advice.
Gotcha. The other thing I wanted to ask, damn it, I had it in my head just now. Okay, let it come back to me. I had another question and it just left.
Okay, we have another
What?
question from the public.
Yeah, so this question is there any association between the vaccine and autism?
So no, actually, you know, and that's the famous study from Andrew Wakefield that claims that there is an association between the MMR, or measles, mumps, and rubella vaccine, and autism. But actually, there have been, I think, 14 peer-reviewed studies since then that have rejected this idea. all saying that there is no link between vaccines, and I think specifically the MMR vaccines, but vaccines overall, and autism. So, it's safe to say, with so many studies, that there's no link. What the situation also was with that specific study was that Andrew Wakefield was a physician who claimed to also serendipitously have the cure for autism. And then after studying, publishing that study that claimed to have a link, he was also trying to sell the cure for autism, which I think most of us know there is no cure for autism. So, that paper has since been redacted from every single medical journal, and you pretty much can't really get a copy of it, which redaction just means that they've been reviewed and shown that it's not true, and so they take it away from the public to show that it's not real. Also, he was stripped of his medical license, so that's something also very serious, and that kind of shows like how serious this claim was taken and how incorrect it was.
Well, I think I just have one last question. Will COVID be a thing? Will COVID become the next flu?
Honestly, it might be. Once we have enough, once we have herd immunity, and if the possibility of the variants not being covered by our vaccines, it might be as easy as everyone knows once a year we all need to go get our booster shots, and every store will have them, and they might become cheaper too. I don't know. If that's what you meant, will it become the next flu? It might just become more normalized that let's all wear masks, let's just keep getting our shots, and we'll all be more aware of it, and it'll be easier to live in a life that way. But we still need to think about the people who can't get vaccinated and try to protect them, because like I said, the hospitalization because of COVID-19 is worse, and there's only so much equipment to go around. So I don't think that it's a good equivalency to say, oh, it's nothing, but maybe it will just become more normal to live in a world where we get vaccinated every now and then.
Okay, awesome. Well, thank you so much, COVID Communications. It was awesome having you. This is going to be a great webinar to send out to people who are still skeptical about the vaccine or just want to know more. Like Catherine said prior to this, it's everyone's right to know what's going on in your body and what you're injecting into your body. So yeah, I really appreciate you guys doing this. And thank you.
Thank you for having us.